back to my YouTube channel. Today we are going to dive into something exciting. I'm going to teach you how to create a coupon recommendation system using machine learning and Streamlit. Whether you are just a beginner or just curious about machine learning, this video is for you. So before jumping into the code, let's quickly understand what machine learning is. Machine learning is like teaching computers to learn from data instead of explicitly programming them. Imagine teaching your friend how to predict which coupon they'll likely redeem based on their habits. That's exactly what our system will do, just with the math and data instead of words. Instead of explicitly programming everything in the machine itself, we are going to let the machine learn. So basically, there are three types of machine learning. Supervised learning. Supervised learning is nothing but the algorithm learns from a labeled data set where each input is paired with the correct output. Um, the model makes prediction when and is corrected when wrong. Okay. It basically learns the relationship between the inputs and outputs. There are several supervised learning algorithms like linear regression, logistic regression, decision trees, etc. And unsupervised learning. This algorithm works with unlabeled data, unlike supervised learning, which works with labeled data. So unsupervised learning is all about finding hidden patterns or grouping without a specific output. Yeah, the output is not explicitly specified. Um, it identifies the structures in the data without guidance, such as grouping similar data points or reducing dimensions. And lastly, reinforcement learning. This algorithm learns by interacting with an environment, like receiving rewards or penalties based on their action. It basically learns from the environment and based on its action, um, the algorithm decides whether it is receiving rewards or penalties. It's like teaching a robot to walk or play games. Today we have chose regression. Regression is a type of supervised learning used for predicting continuous numerical values. The goal is to identify the relationship between the independent variable and the dependent variable. Dependent variable is nothing but value to be predicted. It's the actual value we are going to predict. Like example, let it be a house price. And independent variable features or input that influence the dependent variable, like all other things that actually influence the dependent variable, like example, number of rooms in the house and all other things that are associated with the dependent variable. And final prediction, the model predicts a continuous values such as sales, temperature, or stock prices, etc. Today in our project, we are using gradient boosting, which is an powerful ensemble machine learning technique. Ensemble means nothing but it combines the output of multiple model to make a more accurate prediction. It usually combines the predictions of several weak learners to create a one strong learner. Gradient boosting is ideal for tasks like coupon recommendation system. It can handle the like lot of predictions, which is crucial for recommendation system. It allows for future importance analysis, which helps understand which factor actually influence coupon redemption. Today I have used Streamlit. Streamlit is nothing but it is a Python framework that helps you build interactive web apps. Um, it's usually great for displaying machine learning models, visualization, and more without needing to know HTML and JavaScript, which is a super easy way. So now we are gonna dive into the code. So Streamlit is a toolbox to create user-friendly web apps, as I said before. And I have imported the pandas libraries from Python. It helps you organize and work with data like Excel sheets and NumPy, which is a helper for handling usually the numerical values and calculations. And Scikit-learn, a toolbox for training and testing machine learning models. We have imported train test split from that, which usually divides the data into testing and training, and label encoder helps convert words like yes, no into numbers, numerical values, so like converting the categorical values to numerical values. Here we have imported a gradient boosting regressor, which is a model from machine learning, which we are which is we are implementing in our code today. Here is where the magic starts. The main function holds all the steps for building the app. This line sets the look and feel for the app. It gives the title, coupon recommendation system, and icon, layout, white screen, so everything fits nicely. And sidebar by default. Um, these are some of the CSS which we don't want to dive into deeply today because our main content is about machine learning. This line adds a button for the user to upload the data like a CSV file, like a spreadsheet, and displaying the data set. We are displaying the data set. The data is loaded using the pandas and shows the first few rows of the data set data. As you have declared as data.head, it only reviews like the first few parts of the data. This line lists all the column names in the data set like age, gender, disclaim, income, displays them in a colorful styled list. This line checks whether the particular column is in the data set or not, because we don't want to predict something that isn't there. These are basically the headings, like data preprocessing, converting categorical variables into numerical variables or dummy indicator variables. This is the part where the data gets ready for the model. If the target column has numerical variables, it converts them. Sorry, categorical variables. It converts them into numerical variable. For example, yes, it converts to 1, and for no, it converts to 0. Basically, it converts the category values to numerical values, and converts other columns into dummy indicator variables to handle categorical data. This line splits the data into training and testing set, where the training set it 80% to teach the model, and the testing set is 20% to check how well the model actually learned. Next, we are training the model. We have used the gradient boosting regressor and fit the model. Next, next we are making predictions. We are using the trained model to predict results for the test data. Next, we are evaluating the model, which is an important step. We have used the mean square error. It usually measures how far the predictions are from the actual values, and R squared measures how well the models explains the data, that is closer to one is better. It's like that. This part of the code explains the feature importance. We are taking the target feature, um, which is the dependent variable, which we are going to predict. It generally features the importance of that, shows which column features are most important for prediction, and it usually displays them in a bar chart. This line in particular handles the missing data. If no file is uploaded, the app asks user to upload the file. And this line finally ends with tells the Python to stop running the app when the file is executed. Now we are going to execute our code and see how it's actually working. So it's running in our local host. Now we are gonna upload our particular file. Here I have uploaded my coupon CSV. Here's a data preview. It only reviewing like top of the data. We can also preview it. These are the available columns in the data set. Destination, passenger, temperature, time. Here we have set the target as a destination. Destination, we can also select other columns like it was entered with the color of the website. Need to work on the CSS. Here I have chosen destination, of course, and it does the pre-processing, converting category variables into dummy indicator variables and encoding non-numeric target destination, non-numeric target column destination, and splitting the data into training and testing sets, 80 to 20 split. Model training is complete, and it had predicted about 0.012 as mean squared error, and r squared error at 0.97, which is I guess 97 percentage. Here these are the important features we can set as the target to predict the independent variable. So this is it.